figure that out, you really got to draw a picture of what's going on. This one's not trivial, but it's not that bad. So yeah, you have a tank here, right? And what's being put into the tank? Water. Like water is going into the tank. Yay, exciting. You also know, what is it? It's 12 by 10. And then how high is it? Quick question for you. Is the height of this tank relevant at all in this? No. The question is asking how fast is the water level rising? Does that have anything to do with the height of the tank? No. Like would this, if I change the 20 to 2,000 miles, would that change anything about this question? No. So what am I missing from my picture? What should I also draw in there if I can? What have I not drawn in there? What are we putting into the tank, everybody? We haven't put in water, right? So the water is in here at some level, right? So there's your water. Some people had some trouble with the perspective, but do you see the water that's in there? So water is going into the tank. What do we know? What do we know? Can someone tell me what we know?
dy over dt.
Nope.
We know dv dt.
We know the change in volume, dv dt, is what?
20 feet cubed per hour.
20 cubic feet per what? Hour. And what do we want? We haven't labeled what we want yet.
dH.
Yeah, where's h? H is the water level, right? We want dH dt. Is everybody with me so far?
Yeah.
So what do we, if we know that the volume is changing at 20 cubic feet per hour and we want dH dt, what's the units on dH dt going to be? H is a distance.
Cubic feet per hour.
H is a distance. Feet per hour. Feet per hour, correct? Is it per hour? Yeah, it is per hour. So what do we need to link together? V and what?
H.
V and H. We need to link together V and H. So can someone tell me what volume is with H in there? What's V? Ah, but are these fixed?
Yeah.
So before, I'm going to contradict myself in a second here. That's what some of you might have written down already. Length times width times height. Now, Annie asked me a great question. How would you differentiate that with respect to time? You can do the product rule 3 times. We're not going to do that right now, though. I told you very explicitly before that I would like you, as often as possible, differentiate before you substitute. In this case, though, what could you do first? Substitute first, because the length and the width aren't changing. You could substitute length and width here. What are L and W?
10 times 12.
You have 10 times 12 times H. So what do you have? 120H. That's a heck of a lot easier to differentiate. And could you tell me what the derivative of that is in terms of T?
120 dh dt.
Yeah, so dV dt is equal to 120, what?
dh.
dH dt. And do we already have dV dt?
Yeah.
Yeah, what is dV dt? Oh, it's right here. So what do we end up with? 20 equals 120 dH dt. So if you divide and simplify, you end up with dH dt is equal to 1/6. And what's the unit is? Feet per hour. So you asked before, this is the key here. You have to come up with that relationship. But in this instance, what did I allow you to do? You could substitute right here. That's okay. You just have to be really careful about it. I get really wary when people substitute too early. But in this case, how would you do that if you wanted to? Let me just show you, just as a practice here. So let's say you had L times W times H, and you wanted to use the product rule twice. You have to use the product rule twice. What you do is you treat this as your first function and that as your second function, right? So the derivative you'd have, I'm going to write this in 2 stages here. The derivative of the first times the second plus the first times the derivative of the second. But then what do you have to compute there? What have I not done yet? I haven't done that yet, correct? What is that right there? That's going to be dL dt times W plus L dW what? dt times what? H plus L times W times what? dH dt, right? But you know that L is 10 and H is, no, sorry, L is 10 and W is 12, right? But what? But what do you know about DL? What is DL dt? 0. And what is dW dt? So when you plug that in, what do you get? 0 plus 0 times H plus 10 times 12 times dH dt. What goes away? That goes away. And what are you left with? You end up with the same thing. So in this case, it saves you a bunch of work if you're careful. It's really easy to substitute the wrong thing or the right thing at the wrong time. Be very, very careful about it. It is the same thing. That's why it does work. But that's how you would do it. You'd have to do the product rule twice.
So if you, like I did.